In this problem, we're given a claim that the weights in grams of quarters made after 1964 have a mean equal to 5.67 grams. So we start off by finding the null and alternative hypotheses, and I'm just going to write those off to the side. So since our claim is that the mean is equal to 5.67, that's going to be my null hypothesis. And we want to keep in mind that this is the claim. That's going to be important at the end of the problem. And the alternative hypothesis, since we don't have an indication of greater than or less than, we're going to go with not equal to. So whenever the claim is the null hypothesis, and remember that the null hypothesis has to have an equals sign in there, then the alternative is going to be a not equal to statement. So we're all good for part 1. Now let's take a look at the next part. It asks, what is the test statistic? Well, they actually gave us the test statistic here instead of giving us the data. So we would just put negative 2.53 there because they want it rounded to 2 decimal places. So always be careful and look for how many decimal places they want, because that was a little confusing. They put 3 in the question, but then they only want 2. Next, we are going to find the p-value. So this is where we actually have to do a calculation. We know that we're talking about the t-distribution, which looks a lot like the normal distribution. And we have a two-tailed test. Our test statistic was negative 2.53, and then I'm also going to mark positive 2.53 on my t-distribution. Now my p-value is the area in the tail past the test statistic and the mirrored test statistic on the other side of the distribution. So those two areas together make up the total p-value. So one way to calculate this, I think it's the easiest and most direct way, is to instead of calculating those two separate areas, I'm going to find this center area, but then subtract that from 1. So 1 minus the center is going to give us the total p-value. So how do we find this? We're going to use the t-CDF, because we're using the t-distribution. We have to give the boundaries, the left and right boundaries, so that's negative 2.53 to positive 2.53. And then I give the degrees of freedom. Our sample size is 40, so our degrees of freedom is 39. So we'll put 39 in there. And when I calculate that, and we want to round that to 3 decimal places, so I get 0.018. Oh, or 6. Here we go. Okay, so we got 0.016 for our p-value. And then in the end it says, based on the p-value, there is or is not sufficient evidence at a significance level of 0.01 to warrant rejection of the claim or support the claim. So let's think back to what we had for our null and alternative hypotheses, and remember that the null is the claim. Whenever the null is the claim, we're going to use the word reject in our conclusion. So we want to say whether there was sufficient evidence to warrant rejection of this claim that the mean is equal to 5.76. And when we consider our distribution, I'm going to pause for a second and draw that real quick. Okay, so our blue area is our p-value, and we said that was 0.016. And we're comparing that to alpha, which is 0.01. Since the p-value is greater than alpha, so that means that alpha would be something a little bit more like this. So this area, we don't have to find those critical t-values. We're just comparing the p-value to alpha. And I'm going to say that since the p-value is greater than alpha, then I would fail to reject the null hypothesis. Because what we're saying is, did our test statistic fall into the rejection region, which would be in that red shaded area? And it did not. It's close enough to the center, even though it seems like it's pretty far out, but it's close enough to the center that we do not reject the null hypothesis. So, do I want to reject the claim? I do not. So, there is not sufficient evidence to warrant rejection of the claim. So that's how you do that problem.